A very warm welcome to all of you. Myself Rajan Choudhary, Professor in the Department of Civil Engineering, Indian Institute of Technology, Guwahati, instructor for the NPTEL MOOC course Pavement Construction and Technology funded by Ministry of Education, Government of India. Our today's lecture will be under module 11 and we will discuss about the different payment distresses types which we observe on flexible payments. At the very beginning, I would like to acknowledge the use of text, information, graphs and images sourced from various textbooks, codal standards, journal articles, reports, newsletters and public domain searches. So, payment distresses, as this can be a measure, this is a measure to evaluate the serviceability or condition of a payment surface. So, if there is some distress is there, then we can say that the ability of a payment to serve for the traffic is reduced, and to what extent it is reduced, that is another important aspect. So, we can say distress is the condition of the payment structure that reduces serviceability, or I can say the ability of the surface to serve to the traffic, and ultimately leading to reduction in the serviceability. So, the ability to serve in different terms, specifically in terms of say the roughness or in terms of the safety, if that gets reduced, we can say that the ability to serve to the traffic is getting reduced. So, any condition which affects the serviceability of a payment surface comes under the condition of, or we can call it as payment distress. Now, hot mix asphalt, similar to any other pavement material, is susceptible to development of some distresses, and it can take up different manifestations, or it can take different forms of distresses because of many reasons. Important reasons are the load and the environmental conditions. So, as payment, and during the course of payment life also, because as the payment approaches towards its end of the life, definitely some amount of distress is expected to happen. So, this is a usual phenomenon, but the problem arises when these distresses occur prematurely or at early stages of the life of the payment, then it is a sign of concern. So, as payment approach the end of their design life, the development of distresses is natural and expected, because it is continuously getting subjected to different environmental conditions along with repeated traffic conditions or traffic loadings. So, the occurrence of such distresses is not necessarily a cause of concern unless it occurs prematurely, that is in early stages of life. If that happens in early stages of life, certain distresses, we can say in due course of time some fine cracks may occur in that case, or some loss of fines may be there, or a loss of the frictional resistance, skid resistance of the surface may be there. This will happen during after a good amount of life has passed for that particular payment surface, but this happens prematurely. Cracks are there, depressions are there in early stages of life, then it is a sign of concern. So, we will discuss these distresses, we will discuss the type of distresses, the possible locations where these kind of distresses can happen, and any severity level which are assigned to these distresses as per our codal provisions. So, some of the important codal standards which are referred here are the Code of Practice for Maintenance of Bituminous Roads. We have IRC 82. We have the specifications orange book with us for road and bridge works. We have this manual for construction and supervision of bituminous works. There are many other manuals which discuss about the different type of distresses, like one has been mentioned here, Distress Identification Manual for Long Term Payment Performance Program. This is an FSWA report. Now, the different kind of defects, or I can say the distresses in bituminous surfacings, are usually grouped into the four important categories, or four main categories I can call it. The first one is the surface defects. What it includes? These are, as the word itself says, these are more concentrated towards the top surfacing. So, it says these are primarily include bleeding or fatty surfaces, excessively smooth surfaces, streaking is there, or a lean or hungry surfaces. This is one category which are specifically more related to the surface related defects. So, surface defects which we can. Then comes the category where some cracks are observed. So, this category incorporates the different type of crackings, and what different type of crackings may be there. Hairline cracks may be there, alligator or fatigue cracks may be there, longitudinal cracks may be there, edge cracks are there, the edges along the pavement, the cracks along the pavement edges, shrinkage cracks may be there, and reflection cracks are there. So, these are some typical distresses under the head of cracking. These two we will discuss in today's lecture. Then the other main category is deformation. This specifically when there is some change in shape of the pavement structure is there, that particular one comes under the category of deformation. Here you can see under this particular one, the distresses which comes are rutting, corrugation, shoving, including a part of slippage. We will discuss this one, shallow depressions, settlements and uphills. So, these are certain categories which comes under the distress of deformation. Then we have the disintegration, where there is some breaking of the structure is there, pavement materials breaking of those are there. So, what it comprises of? It comprises of stripping, aggregate loss, raveling, pothole formation and edge breaking. So, these are few distresses. We will discuss the most common distresses which are observed on bituminous or flexible pavements. Now, the important aspect is the location and severity of pavement distresses are critical factors, where it is happening and at what extent it has happened. These two are very important aspects to determine the appropriate maintenance treatment, what type of treatment, what type of materials and what techniques need to be involved or to address those kind of distresses. So, that is why it is important to know what kind of distress has happened, where it has happened and up to what severity level it has happened. So, here we will be discussing these parts in upcoming lectures. Later on we will discuss about the causes of these distresses, and thereafter we will discuss about the different treatment which can be applied for these different distresses. So, beginning with the first distress which is the surface defects. So, are primarily confined to the pavement surfacing, as I mentioned, layer, specifically the top layer, and generally arise due to the use of bitumen, which is what? It is either inadequate quality, you are not using the right grade of bitumen, or improper quantity, or the quantity which is used is not correct. So, either the grade with selection of the binder is not good, whether you are selecting the grade in terms of say tack coat application, there also we select definite grades of emulsions. So, either the selection of grade is improper at the application of tack coat, or the selection of the binder when the bituminous mixes are produced, that time also the selection may not be right grade of binder is selected. And the other aspect is the application quantity. If you are applying excess bitumen, then also some kind of distress may occur, compared to if low application is there, then also some distress can happen. So, we will discuss what are the common surface defects or distresses which are usually observed on bituminous pavements. One is bleeding. So, this is a condition you can see in this particular picture. This is a condition where a film of excess of free bituminous binder appears on the surface. It looks that this particular part which is having a comparatively darker color compared to the remaining surface. So, it appears that there is a free or excess bituminous binder which is present, giving it a shiny glass like reflective appearance. So, you can a part of the carriageway or along the wheel path you can observe a surface where some excess binder appears to be there in comparison to the remaining portion of the carriageway. So, such surface tends, now what happens when this excess binder is there, these surfaces tries to become soft, specifically under hot weather conditions, and slippery when they are cold and under wet weather conditions. So, this sticks in hot weather conditions, this sticks to your vehicle tires, and in cold weather conditions and during rainfall events, it makes your surface slippery. So, that leads to loss of skid resistance. So, this raises the concern with the safety of your users on this kind of surface. So, this phenomenon of bleeding is also known as fatty bituminous surface. So, we are finding that the excess binder is there on the surface. So, this is again a fatty bituminous surface is called in. Now, Where does it usually happens? It mainly develops along the wheel paths. So, in a lane, typically most of the time vehicles try to follow a particular lane, especially the heavy vehicles try to follow a lane with a wheel certain lane in the given carriageway. So, along those ones you can see here this is happening along these two. You can see in this particular one, this is one wheel path, this is the other wheel path, along which you can see the signs of bleeding which has happened. Though it may also appear in isolated spots. Spots here you can see this is an isolated spot, this is an isolated spot. Here also you can see these are the isolated spots are there where it has happened. So, in along the wheel paths it may happen for a longer length, whereas there may be some isolated spots may be there, and it may happen in some specific lanes, specifically the one chances where to happen where you are having the heavy vehicles movement or slow moving vehicles are there. In some cases across the entire carriageway, and this can happen across the entire carriageway also. So, these are some peculiar locations where you can observe bleeding. Severity levels of bleeding. Now, what, because this severity level is usually helpful to decide the maintenance activities. So, the severity of bleeding or fatty surface is classified as low, medium or high. This is most of the distresses are classified in terms of low severity, medium severity and high severity. Now, what is there in case of low severity? It says that the isolated spots, as you can see in this particular case, an affected area of less than 5 meter square per lane kilometer. This is important to understand, this is per lane kilometer. So, one lane is having a width of around 3.5 meters. So, 1 kilometer of that one lane, there should be an area which should be less than 5 meter per square, or if I consider the total area of the carriageway, then it should be below 1%. So, this is, if this is there with this bleeding part, I will call this as a low severity bleeding. The second case is medium severity, when the affected area ranges from 1 to 5% of the carriageway surface. So, instead where it was only less than 1%, here when it is from 1 to 5%, here you can see a large portion of the areas are getting covered. So, if I say if this is in the range from 1 to 5% of your total carriageway area, then I will call it as medium severity. And high severity, in this particular case, extensive bleeding or fatty surface often accompanied by the initiation of shoving. We will discuss some movement of the mix or the failure or the shifting of the mix or sliding of the mix is happening, that is shoving, we will discuss later. So, when this bleeding extends more than a certain extent, chances of initiation of other distresses also arises. So, in this particular case, when it is more than 5% of the surface area of the carriageway, it is considered as high severity cracking, and this is as per IRC 82 2023, the classification of the severity levels are there. Here you can see this is covering more than 5% of this bleeding which is happening is occupying more than 5% of the total area. Now, smooth surface, if the surface becomes highly smooth, highly polished, then it raises the concerns related to the low skid resistance. We have already discussed in the previous talks where we discussed about the measurement of the skid resistance of pavement surfaces, that how important a skid resistance or a frictional resistance is there for the safety of road users. So, a smooth surface is characterized by inadequate skid resistance resulting in slipperiness under wet conditions, and this becomes even more challenging when the surface is wet. This poses significant safety risk, particularly on gradients, curves and intersections where frequent braking is there or where some turning movements are there along the curves where you need a good amount of lateral friction. This smooth surface becomes raises a concerns in regard to the safety of the users. So, where this usually happens, a smooth surface may occur over isolated lanes or across the entire carriageway. So, again specifically many a times these distresses takes place in the lanes which are subjected to heavy movement of heavy axle loads or which are subjected to slow moving traffic, especially the heavy vehicles moves at a slower speed compared to the passenger cars or light motor vehicles. So, those lanes which accommodate the movement of heavier vehicles, usually you will experience these distresses on those lanes, but in India usually lane pattern is currently not followed. So, in that particular case you can find this distress, or if the surface is experiencing distress along the entire width, then there may be some challenge, there may be a localized problem may be there, or it may be a problem with the entire width of your carriageway. So, smooth surface may occur over isolated lanes or across the entire carriageway. This can be a concern. Here you can see along the wheel paths, these smooth surfaces may be there, or it may be there along the entire width of it. So, this entire width may become smooth or slippery in this case. Again, severity levels of smooth surfaces are there, only 2 severity levels are mentioned, and that too in terms of the skid number. We have seen that a desirable skid number is 50. If a good surface is expected to have a skid number of 50. So, here it says when a low severity of this challenge is there with respect to a smooth surface, we call the skid number is in the range of 30 to 40. The desirable is always around 50. Now, high severity, if the skid resistance or the skid number goes below 30, this is the locked wheel tester which we discussed in the previous lectures. So, and this usually will vary by what are the latest guidelines issued by our MORTH and IRC, that specifically with different kind of surfaces, high speed expressways, the requirement of skid number may be higher compared to this one. So, in that case these ranges may also vary. Now, the other kind of pavement surface distress or the surface defect is streaking. Now, is mainly characterized, you can see there are alternate lean, you can see here these are heavy lines of bitumens are there are light lines are there, these are some heavy lines are there. So, it is mainly characterized by alternate lean and heavy lines of bitumen which may appear either in the longitudinal or transverse direction. The causes we will discuss in next lectures, but here how it appears you can see in this particular one there are streaks, there are certain lines are there where some portion you can see a heavy lines of bitumen are there, and the other part you can see that there are lean bitumen which appears to be. A streaking may occur along a single lane or across the carriageway. So, throughout the carriageway you can at various parts you can experience this particular one, that some amount that there are certain sections which are having heavy lines, certain sections which are having light lines. This is another streaking is there. Then the other surface defect is hungry surface. A surface which looks hungry means we are finding it that there may be some loss of fines or there, or inadequate binder is there. So, those kind of surfaces, specifically when fines are less, the surface appears to be hungry because the fines are the one which have the highest amount of binder because they are of high surface area. So, if there are inadequate fines are there, then the surface appears to be hungry. So, a hungry surface is mainly characterized by the loss of fine aggregates. If fines are not there, it appears that it looks like a dry surface often accompanied by fine cracks. Now, these kind of surfaces you can see some fine cracks also gets developed in those surfaces, specifically hungry surfaces, because the cohesion of this matrix is less. Now, location where these hungry surfaces, they may be in full lane or the entire carriageway. So, one particular lane may be affected or the entire carriageway may be affected by it. And specifically like now for these hungry surfaces, there are as such no severity levels which are defined by IRC 82. Now, the other major defect which comes under the distress is the cracking. So, the different type of cracks which are observed on the pavement surfaces, they need to be understood, they need to be identified where these are occurring, and on the basis of severity levels, the causes of those cracks, treatment measures have to be worked out. So, here we will discuss what are those different type of cracks, where are the chances that they occur, and what could be the severity levels if they need to be put under different severity levels. So, first of the distress is the important distress is cracking. So, it is one of the most common form of distresses. This is one of the most common. The other one is a permanent deformation, which is there, which is the other important form of, or the most common form of distress which usually happens on bituminous and flexible pavement. And these cracks may develop due to reasons are there, because repeated axial loads are there, temperature variations are there, some moisture and correction temperature fluctuations may be there in the underlying, inadequate pavement thickness is there, inadequate quality construction or poor quality of construction may be there, poor quality of materials may be there. So, here we will not discuss about the causes of these cracks, we will discuss what types of cracks are there. So, timely sealing. Now, if some cracks are there, here you can see these appears to be closely spaced cracks. So, it is very important to prevent or seal these cracks, which we will further discuss during the maintenance part. Otherwise, they may further get widened up and they may allow the ingress of water through these cracks to the underlying layers, and which will affect our structure integrity of the entire pavement course and the long term performance. So, the different type of cracks which are considered under this particular distress of cracking is hairline cracks, we have alligator or map cracking or fatigue cracking, longitudinal cracking, transverse crack, edge cracking, and the reflection. These are some of the common types of cracks which are observed over the bituminous and flexible pavements. Now, the hairline cracks, as the term itself says, these are very fine cracks, usually less than 1 mm in the width. So, these are, and they are specifically short cracks and which are observed on the surfaces. So, they generally occur as a short, small length, fine and closely spaced cracks are there. You can see with a close look, you can see that there are certain fine cracks which are usually there, and they are isolated, not much of interconnected cracks are there. And usually even they disappear specifically during hot summer conditions. These fine cracks which may be visible, they also disappear specifically because when the material becomes soft under hot weather conditions, they disappear due to the thermal expansion of the bituminous layer. So, then when the material expands, these cracks gets disappeared also. So, these are narrow fine cracks which are there, which comes under the category of hairline cracks. These cracks may be at isolated places or in a lane or through the entire carriageway. This is first category. Now, the second most common cracks which are usually observed are alligator cracks, or they are also known as fatigue cracks, or also known as map cracks. So, fatigue cracking or the alligator cracking is commonly referred or map cracking is characterized by a series of interconnected cracks forming small, you can see these are the say closely spaced irregular blocks are formed on the pavement surface. And why called as a alligator cracking? Because these cracks resembled to the skin of an alligator. So, that is why they are very commonly referred as alligator cracking, closely spaced block patterns which are formed. Now, where they usually happen? Most of the time you will find them happening over the wheel paths, where the wheels of heavy vehicles comes over, or whatever category of vehicles comes over your lane. Those wheel paths you will they are the one where you have maximum chances of fatigue cracking which is there. Now, again they are classified into 3 categories as per IRC 82: low severity fatigue cracking, medium severity fatigue cracking, high severity fatigue cracking. And how they are classified? Low severity says when very narrow cracks of width 1 to 3 mm is there, and with little or no surface deterioration is there, and these cracks are isolated, not interconnected, exhibit negligible distortion, there is no change in the shape of the surface. So, then we can have these low severity cracking. When the crack width ranges from 3 to 6 mm and forming small blocks, then small blocks, because earlier there was no much interconnected cracks were there under the low severity, here then they start forming. So, in due course of time, if they are not addressed, then the low severity cracks may get converted or may move to medium cracking also. So, the crack width expands and they get interconnected. But still at this moment of time you will see that there is no loss of the edges materials are there, spalling is not there, and there is no pumping, there is no say soft soil or the fines coming from these cracks from the underlying layers. So, up to this particular one we considered it as medium severity fatigue cracking or alligator cracking. Now, the one comes is high severity. If a surface is observed where the crack width is exceeding 6 mm and often associated with moderate to severe spalling, breaking of those edges are there, that is happening. Loose or missing pieces of bituminous surface, you can observe there are certain pieces which are lost also here. Signs of pumping, some mud, say a small amount of fines may be coming out through these particular cracks. If these are visible, then this kind of surface. So, you may be witnessing in different cases the surfaces experiencing different levels of fatigue cracking or alligator cracking. So, depending upon the extension of the crack width, depending upon the severity of these cracks in terms of how the cracks are getting interconnected, how closely spaced they are, and whether there are some signs of the pumping is there, some signs of spalling is there, then you can put them into the categories of low, medium and the high severity levels. There is another form which is longitudinal cracking. They, as the term itself says, it mainly runs parallel to the pavement center line or along the roadway. So, this is usually this is what a longitudinal. So, any crack which is found to run parallel to the center line comes under the category of longitudinal cracking. On high traffic volume routes, these cracks may act as an initiation point for fatigue cracking, because see, once here you can see this is a single crack which is happening, but in due course of time, if not addressed, this will get converted into a fatigue cracking. You will have more interconnected, more number of cracks getting developed out of this single crack. Longitudinal cracks can permit water infiltration, because if the width of crack is more there, even fine cracks are there, it allows water to penetrate down into the underlying layers, causing softening and accelerating structure deterioration. So, that then this raises a major concern. If the crack width is good enough to allow water to penetrate down, then it raises other concerns also. They often develop at joints. Now, longitudinal crackings are there, where they often happens at joints, because when we do the construction also, we are not able to do the laying of the entire width in one go. We may have to use multiple times, or adjacent pavers have to move. So, there may be some chances of longitudinal joints which will come up. So, they often develop at joints between the adjacent paving lanes. So, when pavers are run, one paver is run or second paver is run. So, wherever that joint of the asphalt mats will come up, that can be a place where these longitudinal crackings can be observed, or along the edges of the wheel paths specifically, where if this is specifically it appears, if it is the wheel path, then along the edge of the wheel path you are observing this particular one, or near the interface between the pavement and the paved shoulders. If this is again a concern is there, many a times what you have a paved shoulder. So, where you have this interface between your main carriageway and paved shoulder, there also it is many a times observed. So, severity, again how the severity of those are decided, when the crack width of these longitudinal cracks are in the ranges of 1 to 3 mm, occurring infrequently. So, at some locations, far away locations, if it is happening, we call them as low severity cracking. If the width is 3 to 6 mm, occurring moderate frequency, in such then it says medium severity. High severity, when the width is more than 6 mm, it occurs very frequently on the surface, then we can call those longitudinal cracks as high severity cracks. Now, transverse cracking, this is, as the term says, it appears perpendicular to the direction of the travel. So, many a times we call those transverse cracking as low temperature crackings also, when it is related to the stresses, or it is related to the failures considering the low temperature. So then they may be called as low temperature crackings also. So transverse cracks appears perpendicular to the direction of the traffic and may occur either at isolated as a isolated crack, you can see one single crack, or as interconnected cracks forming a series of blocks. There may be interconnected cracks may be there, which forms, this is a single crack, there may be interconnected ones like this way also. So blocks may be formed. So this is known as block cracking. So may occur at isolated points or across the entire carriageway. This is how the transverse cracking. So these are the cracks which are perpendicular to the direction of the travel. Again, depending upon the width of the cracks and how frequently they are occurring, we can call them as low severity cracking, medium severity cracking when 3 to 6 mm wide, high severity cracking more than 6 mm wide, and when they are frequently occurring. So this is how the transverse cracking are classified into different severity levels. Then the edge cracking, the word itself says it occurs at the pavement edges. So the edge cracking refers to the cracks that usually develop parallel to the outer edge of the pavement. So you can see this is the outer edge. So usually these will be parallel to the, here you can see these are occurring parallel to this particular one. So when this is happening, we call them as edge cracking. So they are typically located about 0.3 to 0.5 meter inside the pavement edge. Now their severity level is again here what it mentions, with no breakup or material loss. If there is no loss of material is there, then that will be called as a low severity. If it is accompanied by some breakup and affecting 10% of the cracked length. So some material loss is there and which is affecting 10% of this particular length, we can call. So this is a visual exercise where we have to see whether how much length of it is getting affected by the loss of material or the breakup of material. And then high severity, specifically significant breakup of the material is there and affecting more than 10% of the cracked length. So these are when these are the cracks which are along the pavement edges. So typically along, you can see the remaining surface appears to be intact, only the cracks are there on the pavement edges. Now the last type of distress related to cracking is the reflection cracking. So these are also called sympathetic cracks because they get reflected from the underlying, because of the causes which are there with the underlying courses. So that appear in the bituminous surfacing, especially over joints. If we construct put a bituminous mat over an existing concrete surface, then they can occur over joints or underneath pre-existing cracked pavements. Existing is already having severe cracking, which may be alligator cracking, transverse cracking. If that is getting reflected on the top, we call it as reflection cracks. So these cracks may follow longitudinal depending upon the underlying crack pattern. It may be longitudinal, transverse, diagonal, or block patterns, mainly related to how the crack pattern is there in the underlying courses. So now location of reflection cracks occurs in bituminous pavements, where the chances of these cracks getting reflected from the underlying course to the surface course, where the chances are more, there we will find these reflection crackings more to happen. So most frequently observed in bituminous surfacing or concrete pavements as or cement treated soil bases. So wherever, because there will be some contraction joints will be there, expansion joints will be there. So over those joints, when these cement treated bases are there or the cement concrete pavements are there, or when you have these bituminous overlays, you can observe these kind of reflection cracks. You can see this is a reflection crack which is getting reflected over the surface of it. Can occur in overlays on flexible pavements where existing cracks were not properly treated. May develop at the junction when pavements are widened. This is also usually course. Many a times pavements are widened. So on both the sides they are widened. So specifically where the edges are formed with respect to the old and new pavements, you can get these things getting reflected over the overlay. So existing is having, so when the pavements were widened with cracks occurring precisely along the interface between the old and the widened portions. Reflection cracks, and definitely all cracks may allow water to enter into the underlying layers, and this may hamper the strength of the underlying courses, your granular courses and your subgrade courses, and finally impair your structure integrity of the pavement courses. So, these are the distresses which specifically comes under the two categories. One is the surface defects, second is the cracks. So, these are the commonly occurring distresses falling under the category of surface defects and the cracks. Thank you so much.